Hey everybody, so this is part 2 of the chapter 2 through 4 worksheet. I'll be working on page 3 and 4. So let's get started with number 8. So consider the simple economy where consumers purchase 3 products. Assume that the base year is 2002. We're going to want to calculate the CPI in 2016 and 2017. So just remember that the CPI is the average prices of all goods in the economy. Right, and the formula looks something like this. It's CPI in 2016 is equal to the basket cost in 2016, the current year, divided by the basket cost in 2002, the base year. Right, so this is CPI in current year is equal to the basket cost in the current year divided by the basket cost in the base year. Excuse me. And we're going to multiply that by 100. So it's going to look something like this, right? We're going to take the quantities. We only have one quantity. That's the easy thing with the CPI. And we're going to multiply it by the price in 2016, right? So it's going to be 10 times 110 plus 50 times 45 plus 100 times 6. Let's multiply that, right? Multiply by 100, divide that. So then basket cost in 2002. So now, instead of using prices in 2016, we're going to be using the prices in the base year, right? So we're going to do 10 times 100, 50 times 40, 100 times 5. 10 times 100 plus 50 times 40 plus 100 times 5. And we're going to multiply this by 100. So when you calculate that out, I've done it in advance. This gives us, oh, let me move it a little bit to the side. I realized you can't see that. There we are. This is 112.86. So we're going to repeat the process for 2017. Let me just move this up real quick. There we go. So now we're going to do the CPI. 2017 is equal to the basket cost. 2017 divided by the basket cost in 2002, multiply that by 100. Right, so now we're dealing with 2017, so we're going to use these prices with the same quantity, right? Because we're only given one quantity. So this is 10 times 120 plus 50 times 50 plus 100 times 7. We're going to divide that by the basket cost in the base year, right? Still the same thing as we've done before, 10 times 100 plus 50 times 40 plus 100 times 5. Multiply that out by 100, and this gives me 125.71. So that's the CPI, right? Basket cost in the current year, whatever CPI you're finding, right? So 2016 is our current year here, divided by the basket cost in the base year. 2017 is our current year, so we're going to do the basket cost in 2017 divided by the basket cost in the base year, as always. So now we're going to want to calculate the inflation rate between 2002 and 2016 using the CPI. Let me move this up real quick. All right, so our inflation rate formula looks something like this. Inflation rate, we want it between 2002 and 2016 is equal to the CPI in 2016 minus the CPI in 2002 divided by CPI in 2002. Multiply that by 100. You notice how it's the later year minus the previous year, right? So it's like the year that we have now minus the previous year divided by the previous year. So then when you solve this out, this looks something like taking the CPI from 2016, simple as 112.86 minus, here's the trick, right? What's the CPI in the base year? Well, it's always equal to 100, right? And that comes from, let me try to do it on the side here. Right, CPI in the base year is equal to the basket cost in the base year divided by the basket cost in the base year, right? Because this is the 2002 is our current year. So it's our current year and our base year, right? So CPI in 2002 is equal to the basket cost in 2002 divided by the basket cost in 2002. This gives you 1 over 1 times 100. That's just equal to 100, right? So that's how we end up getting, that's how you know that the CPI in the base year is always equal to 100. That's just a fact, right? So then when you multiply, or when you subtract these numbers and solve, you get 12.86%. Hopefully that makes sense up to this point. So now we're going to calculate the inflation rate using CPI between 2016 and 2017, no longer using the base year. So you'll see how this is different. We're going to do inflation rate 2016, 2017. By now, you should hopefully see a pattern that this is going to be CPI 2017 minus CPI 2016 divided by CPI of 2016. Multiply that by 100, right? And this gives me 125 from above right here. Let me move that over just a tad. 125.71 minus 112.86 divided by 112.86, multiply that by 100, right? And solving this, 11.39%. Hopefully we're good up to this point. If not, let me know in the comments section, please, any questions that you have, concerns about the problems that I'm currently working on. So this is a longer question, but it has to do with the unemployment rate, so it's an important one. In June of 2017, there were 254.4 million individuals in the US that were of working age. That month, there were 160.2 million individuals in the labor force and 94.2 million not in the labor force. Those not in the labor force are divided into those who do not want a job and those that are not actively searching but would take a job if offered one. You learn that of the 153 million workers that are employed, 10 million are involuntary part-time workers. All IPT workers would like to work twice as much and are considered half unemployed. What is the unemployment rate after considering the 10 million involuntary part-time workers? So let's start with a tree, right? So we want the labor force, right? So there's gonna be some number in here. And then the labor force branches out. This is the employed, right? And then this is the unemployed. So how many people are in the labor force? Well, it says right here, 160.2 million, right? 160.2 mil in the labor force. And they're divided into the employed, right here, 153 million. And then the unemployed. Well, how do we figure out how many of these are unemployed? If 153 million are employed, you just subtract, right? So this gives you a 7.2 million who are unemployed. Let me put this in parentheses as well. So now, right, we can go to our involuntary part-time unemployment rate, UE rate, is equal to the unemployed plus 1/2 times involuntary part-time, remember from the formula, divided by labor force. So now we have all the information that we need, right? As long as you take into consideration the 10 million involuntary part-time workers, we know that 7.2 million are unemployed, plus half 10 million involuntary part-time divided by the labor force, which is 160.2 million. And oh yeah, this is also multiplied by 100, right? So we can put that in here, times 100. So solving, you should be getting around 7.62%. That's the unemployment rate after considering the 10 million involuntary part-time workers. All right, let's move on to the last page. Okay, so let me center this table so you can see. So we're going to want to fill in this table before we start to calculate the MPC or any sort of equilibrium. So the first thing you'd want to do is fill in the columns one by one, right? So consumption, we have 850, goes all the way up to 925, right? So we can see that this is an increase by 75. So then we know that this is 1,000, 1,075, 1,150. Planned investment, well, we know that this is all 50, right? Because these are fixed. Same goes here. Government purchases, this is all just fixed. So where things change is right here in that AE column, right? So how do we find our aggregate expenditures? Well, that's just equal to the consumption plus the planned investment plus the government purchases plus the net exports. C plus I plus G plus NX, right? IP. So then what you're going to do from here is we're just simply going to add this column right here. So we're going to add all the planned investment, government purchases, and net exports. And then what we can do is we can add the consumption to these fixed numbers, right? So if you add 50 plus 210 minus 60, this gives you 200. So then it just ends up being consumption plus 200. So, right, we're going to take 850 plus 200, and that's going to give us 1,050. And then we're going to take 925 plus 200, and that should give us 1125. And then we're going to take 1,000 plus 200, 1,200. 1,075 plus the 200 is 1,275. And then lastly, we're going to add the 1,150 plus the 200, and that will give us 1,350. So, right, recap how we did this is we just added C plus I plus G plus NX, but we did kind of a shortcut because we knew that these three columns right here are constant. So we can just add them across, right, and know that each of these is equal. They're just equal to 200, all three of these together, right? So we just add 850 plus 200, 925 plus 200, 1,000 plus 200, and so forth and so on. So while we're at the table, let's calculate our change in inventory. And you should know that this is Y minus AE. Right, so we have Y right here, and we have AE, so we can now calculate our Y minus AE. Negative 50, right, because 1,000 minus 1,050, and now we're taking it 1,100 minus 1,100, and 25, this gives me negative 25. 1,200 minus 1,200, 1,300 minus 1,275 is 25, 1,400 minus 1,350 is 50. So now we have completed our table. Let's move on to question 12. We're going to calculate the MPC of the economy. Right, so your MPC is equal to the change in C divided by the change in Y. So what we can do here is we can really take any 2 points. I'm just going to start with 925 minus 850. You can use any 2 points you would like. 1,100 minus 1,000. This gives me 0.75. Okay, so we know that our MPC is 0.75. Another thing that we should point out right from the start is where's our equilibrium on this table? Well, it's going to be right here, right, where Y is equal to AE. That's where we know where we have our macroeconomic equilibrium. Hopefully you can see that. Let me move that inwards a little bit. There we go. Okay, so 13, we're going to assume that the economy is operating such that the change in inventory is negative 25. What is the level of output at this point? Well, for here, we want to keep in mind that Y bar, the equilibrium, is 1,200. We're going to need that later, right? So there's a formula to calculate how a change in C, I, P, G, or NX, or autonomous consumption, all those factors, basically everything but taxes changes the output. So we're going to have a change in Y is equal to 1 over 1 minus the MPC times the change in inventory, right? Or, sorry, actually this is, I'm jumping ahead just a tad bit. I jumped ahead just a tad bit. Let's back up. So this is actually a lot simpler. It's asking us what is the level of output when the change in inventory is negative 25. Well, this is very simple because we have solved for the change in inventory, right? Change in inventory is right here, negative 25, right? So what's our level of output? Well, Y is equal to 1,100 at the level, at the change in inventory of negative 25, right? So as long as you have this solved, you can go ahead and solve a problem that's asking you about the change in inventory, right? There's no need to do the expenditure multiplier. I was jumping ahead to number 14. So hopefully that makes sense. For this kind of a problem, all you have to do is it's asking you about when the change in inventory is negative 25, what is the level of output at this point? Well, then you just go up here, right? Go across. It's 1,100. All right, now we can go and move on to the expenditure multiplier. So for this kind of a problem, well, you want to keep in mind y bar is 1200, right? So we're going to use our expenditure multiplier of the change in y is equal to 1 over 1 minus MPC times the change in IP, right? So we're going to do 1 over 1 minus 0.75. That's our MPC using number 1 above. And we're going to multiply that by the change in planned investment. So if planned investment increases from 50 to 75, what's our change? Well, our change is 25. It's not negative 25, it's positive because we're going from 50 to 75. Right, so when you solve this, this gives you 100, but this isn't the new equilibrium level of GDP, right? So you started at y bar, it's 1200. What you're gonna do is you're gonna be adding this 100 to get 1300, right? So 1300 is your new equilibrium, right? Because you started at 1200, but the change in GDP that we solved above gave you 100. So when planned investment increases from 50 to 75, well, in that case, right, our change in y was 100. And our new equilibrium, when we add that to the 1200, is 1300. All right, let's move on to number 15. Hopefully you have your table on your worksheet, so I don't need to have it on here as well. Given the level of taxes is 100, what is the autonomous consumption? Well, you solve for autonomous consumption with the consumption function, which is the consumption is equal to autonomous consumption plus MPC times y minus t. So what we're going to do from here, right, we're going to plug and chug. So we're just going to pick some random values from our table to plug in for this formula. But you have to be consistent. You have to use consumption at the level of y that you'll be using here. So let's use the first one. Let's use 850 is equal to, we're solving for autonomous consumption. We know that our MPC is 0.75. Our y at a level at C is equal to 850 is 1000 minus taxes, which are given at 100. 850 is equal to autonomous consumption plus 0.75 times 900, right? So we're going to bring that up here. This, if we solve, this gives me autonomous consumption is equal to 175, right? Because all I'm doing at this point is I am multiplying this out, and then from there, I'm just subtracting that number from 850 to give me 175. Hopefully that makes sense up to this point. Number 16, the economy you're analyzing has an MPC of 0.9. There's a $1,000 increase in government spending. What is the total change in the equilibrium level of output? Change in y, we're going to use the expenditure multiplier here. So change in y is equal to 1 over 1 minus 90 times $1,000 decrease, right? So negative 1,000. Be careful, it's a negative because you're decreasing government spending, right? When you solve this, this gives you negative 10,000. So all this is the expenditure multiplier formula. 1 over 1 minus MPC times the change in G. Hopefully that makes sense up to this point. Lastly, so the economy you're analyzing has an MPC of 0.9. There's a $1,000 increase in taxes. What is the total change in the equilibrium level of output? So the key here is to notice that this formula is a little bit different. It is not 1 over 1 minus MPC. It is negative MPC or 1 minus MPC times change in taxes, right? So negative 0.9, 1 minus 0.9 times, since it's an increase in taxes, we're going to have positive 1,000, right? So solving this gives me negative 9,000. So this means that when we increase taxes by $1,000 with this MPC in this economy, we're going to be decreasing the Y, right? We're decreasing real GDP by 9,000. Oh, sorry, you can't see that. Let me move over just a tad. So this is consistent with the fact that when taxes increase, there's a decrease in Y. And then up here, right, we had a decrease in G, which meant there was a decrease in Y. So you can visit this relationship, right? This is basically fiscal policy, increasing or decreasing taxes and how they have an effect on output. Hopefully this video answered all the questions that you had. If not, please feel free to leave any comments that you have. Thank you.